Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I am joined today by Curtis Rozelle, Project Manager with Jaydee Contractors, Fritz Klingler, he is the President of FK Engineering Associates, and Minnie Panicker, the Manager of Systems Operations Control for GLWA. You may recognize a couple of these faces as they've been Top Project Award winners before, and they're here to talk about another top project, that being the Grand Connection, a major sewer interceptor project in Detroit. So thank you guys all for being here. I appreciate you taking the time, and congratulations once more on a top project win, and for a second one at that for you, Minnie and Fritz.
Thank you.
Thank you.
So could you describe the community that is impacted directly by this project? Your previous top project winning project was a storm sewer interceptor, if I'm not mistaken. How does this combine with that, if it does? And then what is the impact on the community? What type of community is impacted by it?
So GLWA has a very large collection system. We have about 185 miles of large trunk sewers and interceptors. We provide service to about 35% of the Michigan communities. This particular interceptor is almost 12 miles long, and its size varies from 8 feet to 16 feet. To describe that, like if 3 minis stand on top of each other within the interceptor, there will still be room there. So it's that big. I would say with this project, we impacted 10 plus communities, almost like 35% of the Michigan population.
Wow. Okay, so this is impacting a vast majority of people in the area.
That's correct.
So what initiated the need for this project? Why did this need to be done, and what was the catalyst behind that? Curtis, could you enlighten us a little bit on that?
Yeah, so as this is the design build project, so as a contractor, we're responsible for designing and repairing the DRI, all 12 miles of it. As we got into the design phase, we've looked at the flow control required for the extreme downstream reaches of this tunnel, which have not been dewatered or inspected over 100 years. So originally we were looking at, a bypass pumping system to bypass the whole DRI at the Great Lakes Water Authority's pump station. During the design, we realized the pumps had to be so large, and the cost to run these pumps for over a year would be extremely expensive. So we started pulling as-builts, working with ASI, our sub-consultant for the flow control. We mapped out that the two sewers were actually 300 feet apart at one point, and we said, we really have to evaluate if we can connect them and do a passive diversion of the DRI, so we can eliminate majority of the bypass pumping and actually install a gate, divert the flow, and be able to work in the DRI in the dry. So after evaluating all this, we decided that it was cost effective to do this approach. And then we worked with FK, which Fritz will elaborate more in the upcoming questions on the best location to put this connection. So all in all, GLWA got a long-term asset out of it and the ability to divert the DRI passively.
Yeah, one of the major considerations for this project was flow control, and that was something that was mentioned in the nomination form. What were some of those considerations that were necessary for that?
Well, as Curtis had mentioned and Minnie's mentioned, we serve the community served is about most of Michigan and or much of Michigan. 3 main interceptors converge at the wastewater treatment plant to provide service to this entire area. And as Curtis mentioned, two of them happen to come very close to each other. So it's this kind of a little bit of creative thinking by Applied Science, our hydraulic subcontractor, and others, in order to conceive of this potential solution. What we're doing is diverting the entire dry weather flow from one system to the other. And this allowed essentially dewatered conditions for the lower 3 miles of this this major interceptor. So very difficult otherwise to perform the kind of extensive repairs that we foresaw in that lower section. For the work itself, much of the work was done without consideration for flow control in terms of building the tunnels, putting the shafts in between, and getting the work done. Obviously, to make the final connections was quite a task in terms of coordination with the plant and with upstream customers in order to get flows down so low in both interceptors in two separate stages in order to make those final connections at near the lower quarter point of each sewer. So that was quite tricky. Came off without a hitch after a number of kind of dry run practice attempts, and the system is in place and functional now.
Well, one of the things too that was mentioned was just the location, kind of a more urban environment there, and some of the challenges presented there. What were some of those challenges, and how did you aim to overcome those through the course of the project?
Right. So Curtis had mentioned that we were as close as about 300 feet between these two major interceptors. That would have been the ideal location to divert flow from one to the other. Turns out we are in a very, very heavily developed area in Detroit. We had the Ambassador Bridge right there. We had a number of major large diameter local sewers right there. Electrical, water, the buildings, you name it. As a result, we had to move the connection a bit farther downstream where the two sewers were about close to 1,000 feet apart. So had to spend a little more in order to make that work. That location didn't come without its own challenges with all the utilities you might expect. And in fact, the one connection had to be made to the northern major sewer that would be on the receiving end of flow. That had to be made as a blind tap to the side of that sewer. Quite a challenge to go into a 12-foot sewer with a 10-foot sewer without any sort of shaft right there. That was because the new International Bridge construction used that street as their main primary traffic route. So that, among many, many other complications, had to be considered and were overcome. And it came off without a hitch. We did have a fairly extensive geotechnical instrumentation program, which, along with some predetermined limits, helped us to make sure that we were not damaging adjacent buildings, the overlying roadway, utilities, and the like.
Yeah, as is always the case with something like this, there's just a lot of different pieces you have to think about in terms of like what's under the ground. And so running into all of those challenges, it kind of doesn't matter where you are, especially in an urban environment, you're going to run into something somewhere along the lines. You got to account for it. But Minnie, I wanted to ask you about this project too, in terms of the broader ideas of it and how that can help other collection systems across the country. This seemed to be something that through the nomination form, you said you hope this could be a really good educational tool and case study for other utilities in the United States. What are some things that people could learn from this? How could they adopt some of the things you did to make their next collection systems project better?
I would say thinking outside the box helps. The delivery method for this project was design build. In the beginning, they had some other conceptual ideas about the design, but somewhere along the line, they decided to think outside the box. They decided to think like, if we can divert the flow from one interceptor to the other. Like Curtis mentioned, just because they thought outside the box, we were able to come up with a new asset, and that gives more redundancy to the system. Also, GLWA was open to receive the idea. Like we were also thinking outside the box instead of going with the traditional design build. Traditional design and build. We were, for this project, we were going with the design build. And then when the novel idea came, we were open to receive that also. So if we hadn't decided to go in this route, we could have spent like much more money or similar amount of money for temporary bypass pumping. In this case, we ended up having a new asset that gives like much more redundancy to the entire collection system. So I would say always try to think outside the box.
Great. Well, thank you guys so much for taking the time with me and talking a little bit more about this project. And for everybody who is watching this interview, you can check out our video description below for some more details on the project. We'll have an article write-up as well. And once more to everyone here, thank you so much and congratulations once again on a top project for 2022.
Thank
Thank
you.
you.
Thank you.